We're going to combine a couple of things that we've been talking about to solve exponential equations. So the first thing is that if we were to try and look at this by switching to common bases, okay? If we had this, I would want to write 88 as some power of 12. So if we think of 12 to the first, that's 12. If I think of 12 squared, that's really 144. Well, that doesn't really work. If I think of 12, there's not a number that I can multiply by itself to get to 12. That's a nice number. I mean, you could get the square root of 12 would work, but so that doesn't really help us, right? So then we're out of ideas for switching to a common base. So then what we can do, the other thing that we've been working with is we just had some equations where we had like y equals 12 to the p, and we were finding the inverse equation. So when we find the inverse, we switched. So we did p equals, we switched x and y. So in this case, the x is p. So p equals 12 to the y, and then we solved for y. Now remember, this is an exponential kind of function. So if you are undoing an exponential, the way that you undo an exponential is that you switch to a log. The way that you switch to a log, you start by identifying the base. Our base is 12, so log base 12. And then I like to think of it as hopscotching around the equal sign. So log base 12, hop to the other side of p, hop back over, equals y, right? So we're doing this same kind of thing, except for instead of having a y here, we just have a number, right? So then there's just an extra step at the end that we would be solving, okay? Now, the first thing when we were finding our inverses after we switched x and y is that you're getting the kind of function by itself. So in this case, our functions are exponential functions. So I want to get the exponential alone, which means I need the base and the exponent alone. So I want to make sure that you see how to get the base and the exponent alone. So I'm going to highlight what our base and exponent is. So on this one, we want the 12p alone. Here we want the 16k alone, the 10m alone. Here, it's just the 17 to the p that we want alone. Just the 18 to the x, just the 2 to the 6v. Here we want the 10 to the x plus 6. Here we want just the 16 to the 2r. Here we want the 19 to the 8 minus 3p. Here we want the 18 to the 4n minus 1. Right? And that's what we want to get alone. Okay? So you're getting alone whatever the exponential function is, which is the base and the exponent. Okay? So our first step when we're solving the equation is not to switch x and y because we're not doing inverses, is that you want to get the exponential alone, and you're doing the order of operations backwards. So you're taking your PEMDAS, or please excuse my dear Aunt Sally, or whatever you learned, and you're undoing that. So I'm going to start by undoing any add subtract. So if I look here, is there any add subtract outside of the exponent? No, there's not. So then I'm going to look, well, is there any multiply divide? Well, there's not. There's nothing outside of it. So then notice our exponents. We want to undo our exponents. So in this case, this is an exponential. So the way that we undo exponentials is with logarithms. So I'm going to switch to a logarithm. So this will be log base 12, hop to the other side of 88, hop back equals p. Which, notice, this looks very much like this, except for our p is now replaced with the 88. Right? So because we had switched x and y here, the p is in different spots on these ones because we had switched the x and y. So here, then we know how to put this in the calculator. If you've forgotten, you're going to do log 88 divided by log 12. Okay? I like to remember that the base goes in the bottom. This is your change of base formula. Okay? Your log on your calculator, if you have a TI calculator, is left of number 7, so you can just do log 88, make sure you close your parentheses, divided by log 12, and then that gives you, oops, p is 1.80. Notice I look at my instructions, we're rounding to the nearest 10,000th, that's 4 decimals, so 1.8018. After the 8, the second 8 is a 1, so that means I keep it as is, so then this is my answer. So it's very similar to our process for solving to find the inverse equation, except for now that we have this end step right here that we're looking at. Okay. So if we look, let's skip to number 8 and look there. So here I want to undo any add subtract. There's no add subtract outside the exponent and base, so I'm going to divide by 4 because the next thing we're getting rid of is the multiply divide. So I have 17 to the p equals 85 fourths. Now I know in a minute I'm going to need to put things into a calculator, so I'm just going to leave this as 85 fourths. Okay. Now my base and exponent are alone, so now I want to undo the exponential. So to undo the exponential, we switch to log. Now, if you don't like the way of switching to log that I've been doing, you also can take the log of both sides, and that will end up switching it as well. So you still need to be able to identify the base. The base is 17, so here I would do log base 17 of 17 to the p, and log base 17 of 85 fourths. Notice our log goes on both the left side, just like when we're taking a square root, it goes on the left side. Here, the log base 17 of 17 undoes each other, so then we're left with p equals, and then on the right side we have log base 17 of 85 fourths. Right? So that's another way that you could look at it. So now I'm going to put that in my calculator. If you have a TI-84, if you go math and then up to letter A, it will have log base, and it will make it look like this on your calculator. So your calculator will prompt you log, and then it has boxes like that. So then you can put that in there. If not, all of your calculators, even your phone calculator, you have to flip it sideways, should have a log, and then you can always do it with the change of base formula. So the base goes in the bottom. So log 85 fourths divided by log 17. Right? So that way it always works as well. So if we do log 85 fourths divided by log of 17, it gives us 1.078. After my next number is a 7, after the 7 is a 5, so that means that it becomes 1.0788 because the 5 is greater than or equal to 5, so that bumps it up to an 8. So then that equals our p-value. Okay. So if we look at this one, as we have more things around it that are happening outside of the exponent and base. So I undo add subtract first, so I'm going to subtract 9. So we have 5 times 18 to the x equals 63 minus 9, which gives us 54. So then we are going to divide by 5, because we get rid of multiplying and dividing next. So then we have 18 to the x equals 54 fifths. Again, I know I'm going to have to go to my calculator in a minute, so I'm just going to write it as 54 fifths. I'm going to switch to log because we're undoing an exponential. So we do the base is 18, so log base 18 of, hop to the other side, so 54 fifths, hop to the exponent equals x. So now I'm going to put that in my calculator, so I'm going to do log 54 fifths divided by log 5. And that gives us x equals 1.47849. So then after the 9, or after the 4 is a 9, so then that bumps it up to a 5. So 1.4785. Now, let's look at this one. Okay? So if we look at this one, we still are trying to get the base and the exponent alone. So this is the part I want alone. So I need to undo the add subtract, then undo the multiply. So I'm going to add 1, get 5 times 16 to the 2r equals 67. So I'm still trying to get the base by itself, so I want to get rid of the 5. So we're going to divide by 5. So we get 16 to the 2r equals 67 fifths. Now I know I'm going to go to my calculator in just a minute, so I'm just leaving it as 67 fifths, and then when I go to the calculator, I'll just use that then. So we want to undo the exponential because the base is all by itself. So to undo exponentials, we switch to a log. So the base is 16, so log base 16, hop to the other side of 67 fifths, hop back, equals 2r. So in the calculator, remember you do log of divided by log of the base. Base goes in the bottom. That's how I help myself remember. So log of 67/5, close my parenthesis, divided by log 16, or if you've got a newer TI, you can do math, and then up to letter A, which is log base, and then it will look in your calculator like this, and then you can just write it like it looks on your paper. So then we get 0.936 equals 2r. Then I want to get r by itself, so we're undoing timesing by 2 by dividing by 2. So I just hit divide by 2 on my calculator, so our r is 0.468. Let's look at 2 more. So we have this one right here, right? It's long, longer than the ones that we've done, but it's still fine to be looking at. Okay. So we're going to get the base and the exponent alone. So I want this part alone here. So I'm going to subtract 7 first. We have -9 times 18. Sometimes I like to write my base in parentheses. I just think it looks nicer. So now I'm going to divide by -9. So I'm going to have 18 to the 5p plus 9. The only simplification I'm going to do here is that negative divided by negative is positive, so I'm just going to write it as 49/9. So now our base is alone, so now I'm going to switch to exponential, or from exponential to logarithm. So we have log base 18, that's our base, hop to the other side, so of 49/9 equals hop to the other side. So we have log base 18 of 49/9 equals 5p plus 9. So I'm going to put log 49/9, oops, I typed 79, 49/9 divided by log 18 gives us 0.5863 when I round. So I'm rounding on paper, but then when I go to do this next part, I'm not rounding on my calculator. So it's fine to round on your paper, and then to get your most precise answer, you should be using second answer, which is your negative button on your calculator. So I'm going to subtract 9. So then that gives me -8.4137 equals 5p. So then I'm going to divide by 5. So then we get -1.6827. After the 7's a 4. So that remains the same. Okay. Now, if we look at this one over here, this is e. Okay. E is just a number just like pi is. Right? We just use a letter to represent the number. Okay. So there's nothing outside the exponent, so I'm just going to switch forms. So when we do log base e, remember log base e, we really write it as ln, which stands for natural log. The reason it's ln and not nl is because it was in a different language than English, where they say log natural instead of natural log like we do. So their grammar is just different. So that's why it's ln. So we do the natural log of, hop to the other side, 48, hop back, equals 4 minus 7n. There's a natural log button on your calculator. It's left of number 4, so you just type it in so it literally looks like this on your calculator. So that gives you 3.8712 equals 4 minus 7n. So now I want to undo, add, subtract. So this is really adding 4, so I want to undo that with subtracting 4. So if I subtract 4, again, I'm using second answer so that I don't get a rounding error. So -0.1288 equals -7n. So now I want to undo timesing by -7, so I'm going to divide by -7. So then we get n equals 0.018. After the 3 is a 9, so 0.0184 is our n value. Okay. Now, you can check your answers on these. So if I wanted to check my answer, I would plug this into here. So I can do e to the e to the on your TI calculator is second, and then natural log. So e to the, and then I'm going to put second answer for my, or I'm going to do 4 minus 7 times second answer. So your answer button is the negative sign. And then when I put that in, I get exactly the 48. So you can check your answers as well. And that's how you solve log for exponential equations.